Day 410 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 698, partition to k equals some subsets. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go in and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array nums and an integer k, return true if it is possible to divide this array into k non-empty subsets whose sums are all equal. All right, y'all, so that sounds simple enough, but let's go ahead and take a look at these examples anyway, just to make sure that we are doing this problem correctly. So in example 1, we have the input nums equals an array of integers 4, 3, 2, 3, 5, 2, and 1. K equals 4. The output is true. Explanation says it is possible to divide it into 4 subsets, 5, 1, 4, 2, 3, 2, 3, with all having equal sums. So let's go ahead and break this down one step further just to make sure that we really understand what's going on. So we have this input array of integers nums, and then we have k equals 4. We need to return a Boolean true or false if it's possible to create 4 subsets, or excuse me, not 4 subsets, but, the split into k, which will be 4 non-empty subsets whose sums are all equal. So in this case, the 4 subsets, because k equals 4, are right here, right? So with all, and if you notice, all 4 of these subsets have equal sum. This is 5, this is equal to 5, 1 plus 4 is equal to 5, 2 plus 3 is equal to 5, and 2 plus 3 equals 5, right? So we get this 5 right here, that's one subset. We have this 1 right here and a 4 right here, that's another subset. Then we have a 2 right here and a 3 right here, that's a subset. And we also have a 2 right here and a 3 right here, that's a subset. Now it's important to remember we are not returning the subsets themselves. We're just returning a Boolean, true or false, to see if it is possible or not, right? So we need to keep that in mind as we're writing our code. But as you can see, it's that simple. That's all we're doing. Now let's take a look at example 2, where it gives us an example where it's impossible, right? So in example 2, we have the input nums equals an array of integers 1, 2, 3, and 4. This time k equals 3 and the output is false. So since k equals 3, that means we would have to break it up into 3 subsets, right? And they all have to have equal sums. So just looking at this, you might think, oh, we could have one subset that's 3. This could be a subset which would equal 3 as well, where the sum will equal 3. But then we have this 4, which would mess everything up, so we can't do it. Same thing if, say, we started with the 4, and then we was like, maybe we could use this 3 and a 1, that equals 4 as well. We would still be left with this 2, which doesn't equal 4. So in the end, there's plenty of different ways we may be able to break it up, but in the end, the output will be false either way. So now that we understand the question, y'all, let's get into the fun part, the actual solution. Solution's not that difficult, so let's get started. Now, the first thing we're going to do is we're going to calculate the total sum of the array. So for that, we could just come right here. We could say, let sum equal nums dot reduce, open up the parentheses, 0, comma, plus. Now what this is going to do is going to take our input nums, or this an array of integers, and it's going to, with this right here, is going to add all of these numbers together starting from 0. Boom. So in the end, that'll get us the total sum of every element in the array. Boom. Then after we do that, we need to check if the total sum is not divisible by k. It's impossible to partition it evenly. So for that, we could use a guard statement. We could say guard sum mod k equals 0, else we could open up the brackets and we could return false, just like that, right? Because this right here is going to get us the remainder of sum divided by k, and if the sum is If it has a remainder, that means it's impossible to partition equally. But if there is no remainder or the remainder is 0, then we can continue. Now we need to sort the numbers in descending order. We're going to use the greedy approach to place bigger numbers first. So we'll come underneath this. We'll say let nums equal nums dot sorted, open up the parentheses by colon, and then put the greater than sign, which is going to sort them in descending order. Now we're going to determine the target sum for each subset. So we're going to come right here and we're going to say let target equal sum divided by k. Boom. And now we need to create an array to track the remaining capacity in each bucket or subset. So we declare variable, we call it buckets, and we'll set that equal to an array, open up the parentheses of repeating colon target comma count to k. Boom. Now we're going to create a helper function that we are going to recursively call to try placing the nums index, or the nums value, not the index, sorry, the nums of the index or the nums value into one of the k buckets. So for that, we're going to declare a function. Inside, it's going to be nested inside the main function. We're going to say func bucket next value, open up the parentheses, index colon, it's going to be an integer, and it's going to return a bool, just like that. Boom. Now we're going to create a base case to see if all numbers are successfully placed. So we're going to say guard index is less than nums.count, else we can open up the brackets and we can return true. Boom, just like that. Now we need to get the current number to place, so we'll say let val equal nums square bracket index. Boom, and now we're going to try to place val into one of the k buckets. So we'll come underneath this and we'll say for b and 0 dot dot less than sign k. We're going to open up the brackets. We're going to check if the current bucket has enough room for the val. So we're going to say if buckets square bracket b is greater than or equal to val, we're going to open up the brackets. We're going to place val into the bucket by saying bucket square bracket b minus equals val, just like that. Or so, yeah. Then we're going to recursively try placing the next number. So we're going to come underneath this and we're going to say if this is the function that we are writing, so this is where the recursion comes in. We're going to say if bucket next value, open up the parentheses, index colon index plus 1, come outside of that, we're going to open up the brackets and we can say return true because a successful partition has been found. Then we're going to backtrack and remove val from the bucket by coming underneath this if statement and saying buckets square bracket b plus sorry y'all, come outside the square bracket, say plus equals val. Boom, just like that. Then we need to, if the bucket was untouched or equal to target and val couldn't fit, then there's no point in trying the same for the other empty buckets. So we come underneath this if, start a new if, and say if bucket square bracket b equals target, then we could just open up the bracket and say return false. Sorry y'all, we don't need that period right there. Then if no valid bucket placement for val is found at this level, then we come right here and we could just return false. And then we need to start the recursive placement from index 0. So we still need to call this recursive function. So for that, we come right here and we say return bucket. It's going to be bucket next value. Open up the parentheses. We're going to say index colon 0. Or no comma, just index colon 0. So that should be all she wrote, y'all. Let's give it a run. Make sure it runs properly before we submit it. Okay, we have an error. Can I find bucket? I think it should be buckets with an S. So let's go ahead and give it a run again. Let's see, and that did the trick. It's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Ooh, look at that. 4 milliseconds, 35.71% of users. We could definitely get those numbers up, but right now we just want to be able to solve the problem that is presented to us. And I feel like this is a good solution for that, y'all. This is an easy to understand solution, and we'll be able to use what we learned from this solution in future solutions, which is what is important in our learning LeetCode journey. So with that being said, y'all, make sure you get one more look at the code. This is the top part. This is the middle part, and then this is the bottom part right here. And yeah, y'all, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.